What if we could build a structure so vast that it could capture all the energy of a star? Meet the Dyson Sphere, the ultimate megastructure in theoretical science, designed and built around a star to collect all of its radiant energy. Get ready to time travel into the future. It would surprise you to know that an average star at a random position in the universe generates about 40 quadrillion kilowatt hours in 1 year. That's over 300 times the amount of energy the entire humankind consumes. Imagine filling your vehicle's tank not with gasoline, but with pure sunshine. This seems impossible, but not for too long. The discovery of this possibility led to the construction of the Dyson Sphere. Dyson spheres are hypothetical artificial megastructures built around a star to collect all of its radiant energy. It's in the design of humans to strive to advance to the next level. So the whole concept was first the brainchild of Olaf Stapledon from his 1937 science fiction novel Star Maker. But the physicist and mathematician Freeman Dyson was the first to give life to the concept, what became known as the Dyson Sphere. In his 1960 science paper, Search for Artificial Stellar Sources of Infrared Radiation, Freeman Dyson suggested that technological extraterrestrial civilizations can build a cloud of solar energy collectors that would surround their star once the requirements exceed what can be generated from the home planet's resources alone. This is so because only a tiny fraction of a star's energy emissions reach the surface of any orbiting planet. So building structures around the star would enable a civilization to harvest way more energy than usual. This sphere would be composed of a shell of solar panels around the star, so that all of its energy radiated would hit one of these panels, where it could be collected and used. And so a Dyson Sphere would not only enhance the luxury of living, but also gather extraordinary amounts of energy to ensure more efficiency on the planet. So maybe we don't need artificial energy sources anymore. How's that? Many people imagine a Dyson Sphere as one solid hollow ball wrapped around a star. Well, that would be wrong. If you were to build a Dyson Sphere, then you would make it out of elements like solar panels or mirrors that either orbit your star or hover above its surface. However, there are several types of Dyson structures, each one capturing more energy from the star than the last. Think of Dyson Swarm as a gigantic collection of satellites and solar energy collectors that orbit a star, harvesting and transferring its energy to other planets. The energy would be transferred wirelessly between the individual components and Earth. Instead, millions of mirrors could be used to focus light onto a smaller number of collectors. Unlike the Dyson Sphere, which seems more expensive than the resources of all the nations on Earth due to the insanely high cost of creating a solid sphere around the Sun, the Dyson Swarm is more achievable. It would essentially involve individual solar panels surrounding the Sun and absorbing its light energy into solar collectors for practical use. What we as a species produce yearly would be nothing compared to the energy the Dyson Swarm would provide. But how about we compare it with a Dyson bubble? A Dyson bubble is a different and more realistic Dyson Sphere design. However, it shares some similarities with Dyson Swarm. Rather than being a complete shell, a Dyson bubble is composed of multiple individual satellites called statites. These statites don't orbit around the star like the Dyson Swarm. Rather, they hover at a fixed spot, using something like a solar sail to allow radiation pressure to counteract the star's gravity. So people often wonder if a statite is even possible. After all, radiation pressure is a very weak force. Well, technically, it can. The gravity force a statite experiences depends on its mass, and the radiation pressure force depends on its surface area and how strong its reflection is. This means that a wide, very shiny structure can be used as a statite. Graphene would have been a perfect choice because it has a density low enough, but it isn't reflective. So let's say a new material will have to be created. However, the third type of Dyson Sphere is the Dyson shell. This is a large, hollow ring surrounding a star, made up of floating power collectors, factories, and habitats. It's just about the size of a planet's orbit and would be habitable on the inside. However, this Dyson might seem impossible because the amount of resources and energy required to build such a structure is outrageously high. So let's take our solar system for instance. To build a Dyson shell, it has to be as large as the Earth's orbit. Constructing a structure that huge would require more material than our entire solar system could provide. But we're not ruling it out entirely as we look forward to a future possibility. Every second, the Earth receives about 400 trillion watts worth of the sun's power. Yeah, you heard that right. But because of its distance and direction, most of it doesn't reach our planet. Surrounding the sun with an energy-capturing megastructure like a Dyson Sphere would be a more efficient way to use all the sun's juices. It seizes solar energy and converts it into the kinds of energy that we can use to power vehicles, computers, or other advanced power-draining technologies we will develop in the next million years. A Dyson Sphere would give access to practically unlimited energy, powering everything from advanced technology and space travel to entire planets or artificial habitats. If this is achieved, we'd have 550 million times more surface area than our whole planet, all catching rays to send back to Earth in the form of raw power. Dyson Spheres are still very much in the imaginary stage of development, but its reality is closer than you can imagine. If you've watched this video to this point, then you'll love other amazing science videos we've created just for you. So hit the subscribe button now. Now, while it's theoretically possible, a Dyson Sphere would require an unbelievable amount of materials and advanced engineering techniques that are far beyond our current reach. The sun is massive, so to surround it with solar panels, we would need to disassemble an entire planet. In this case, the easiest victim would be Mercury. 1, because it's the closest to the sun. 2, because it has no atmosphere. And 3, because it only has about a third of the surface gravity of Earth and is made up of 30% silicate and 70% metal, the perfect materials for creating the sphere. However, how possible is this? Not to mention that it would take 31 years and 85 days to completely dismantle Mercury, even though it would be carried out by robots. Aside from that, transmitting power back to Earth is also another problem. Wireless transmission of electricity is possible, but not exactly as easy as it seems. Currently, we are not able to transmit any of all that glorious solar energy across the 102.1 million kilometers between Mercury and Earth. Let's admit it, this is indeed a huge challenge. Building a Dyson Sphere would be the largest, most ambitious project undertaken by humanity and would require global cooperation on a level we just haven't reached yet. Aside from the mountains of challenges standing between fiction and reality of building the first ever Dyson Sphere, we won't forget to add the possible risks that come along with it. Speaking of tearing down Mercury, the potential catastrophe is scary alone. If we decide to go for building a Dyson shell that will enclose the sun, this would cause many potential problems, including space debris colliding with the sphere, inefficiencies in transporting the energy back to Earth, plus having to perform maintenance on a megastructure that is dangerously close to the sun. Or at worst, it could crash into the sun, causing life-threatening impacts on the Earth. So yeah, you can imagine that. While this might all sound like an excerpt cut out of a sci-fi storybook, Dyson Spheres were theorized as a way to detect alien life. Scientists say they found potential evidence. Researchers have identified at least 7 stars in our galaxy that may be surrounded by super advanced alien megastructures, which would give off infrared radiation, searching for that byproduct that would be a viable method for finding extraterrestrial life. However, we can't cancel out the reality of this project yet. Though it might look like a tough one, it's just unimaginable how far humans can go in trying to harness the cosmos. But while we wait for that to happen, don't forget to hit that subscribe button to learn more about human space exploration.